SNMP, Simple Network Management Protocol, is the same tool that is trusted by companies to monitor their networks, infrastructure, VMs, and other systems worldwide. And there's no easier way to start learning SNMP than with a Raspberry Pi. In today's video, I'll show you how to set up SNMP, configure everything you need, and monitor it all like a pro. That being said, let's go engineer some stuff. To get started, we're going to first do a sudo apt update before we get everything squared away so we can make sure we can update to the right packages. And then we're going to do a sudo apt install SNMP and SNMPD. This will install the SNMP client tools as well as the SNMP daemon itself that we're going to configure in the next steps. Now, if we do a systemctl status SNMPD, we can ensure that the SNMP daemon is running as expected, it's enabled, it's loaded, and it's active as expected. And when we look at the logs, we see no bad error messages, meaning we should be good to go for this then. Now, if we do an ls on etc snmp, we're going to see three files. The snmp.conf, which is going to store our client config for things like MIBS, default community string, and is going to be used by tools like snmpget, snmpwalk, etc. And the second file we're going to see is snmpd.conf. This is where we configure the snmpd daemon, which will allow us to configure all of the access level for our tree, as well as a bunch of other stuff like who can access it, what IP access there is, as well as v2 and v3 snmp detail. The final thing we're going to see now here as well is the snmpd.conf.d directory. So if we wanted to, instead of having a single monolithic snmpd.conf, we could divide it up into smaller configuration files that would tackle a specific purpose just to make it easier to manage. For the purpose of this video, we're going to skip that, but it's helpful to know. Who doesn't love a good walk? That's why, thankfully, once we have SNMP installed, we can get rolling pretty quickly right out of the box. So if we do an SNMP walk -v2c-c public and then our localhost IP address, we can see it gives us a multitude of OIDs, object IDs in SNMP terms, including things of what distro we're running, who we are, where the system is located. No, it's not actually sitting on the dock of the bay, unfortunately. I wish. As well as a whole bunch of information. One of the biggest things, however, like I said, is they're all in OID format. And while this is helpful from a visual standpoint, it's not very easy to remember all of these. So instead, I'm going to show you how to install MIBS so we can resolve these with names instead of numerically. If we cat the output of etc snmp snmp.conf, as we can see with the disclaimer in the comments section of this file that due to licensing issues, snmp MIBS files are not included by default, and also they are disabled loading them by default. To fix this, we're going to do one of two things. We're going to comment out the line it suggests to comment for the MIBS so we can enable the loading. And two, we're going to download the MIBS downloader package that will allow us to get the MIBS files so they can translate correctly. To install the MIBS package, we'll do sudo apt install snmp-mibs-downloader. As the install goes by, we'll see it installing all the lines of the MIBS files that we need so we can resolve our OIDs. Now, doing an ls on user share snmp MIBS, we can look at the directories we have that have a bunch of MIBS files in itself, as well as the individual MIBS files. These files are what will be used in our SNMP configuration to resolve our object OIDs, and this way we can use names instead of just numerical identifiers. As mentioned previously, we're going to need to edit our snmp.conf by doing a sudo nano etc snmp snmp.conf. Now, once we're in here, we're going to need to find our MIBS line and comment that out. Then after saving and closing our file, what's left to do is to restart so we can get our changes applied, which will be a sudo systemctl restart snmpd. So now that we have our MIBS set up, if we do snmp walk -v2c-c public and then our localhost IP address, we'll see that instead of the full OIDs in numeric form, we're going to see them all as the MIB name, which is the management information base. You can think of it as a dictionary that maps human readable names to numeric OIDs. The object name, in this case, if you look at the top one, it'd be system description, and the instance identifier, which in this case is 0 because there's only a singular system description. The cool thing about this MIB name, object name, and instance identifier syntax is we can easily pick off individual items that we want to query from our tree. So in this case, I could look at the system location and the the sysname. Now, I know what you might be thinking, Sam, there's all kinds of information I want to look at my Raspberry Pi that isn't present in this tree. But don't worry, because in the next step, we're going to expand our config to look at the whole tree and look at things like CPU data, temperature data, Ethernet information, disk I/O, and all kinds of other fun stuff that we can monitor about our Raspberry Pi. Now, in order to actually access SNMP outside of the local host of the Raspberry Pi, so we can actually monitor it from another computer and make use of what SNMP is for, we're going to need to edit the SNMPD config. So we'll be doing sudo nano/etc snmp snmpd.conf, and then once we have that, we can see the whole snmpd.conf right here. So to start, we can edit the sys location. I put Sam's desk because it's sitting right here next to me on my lovely desk. Sys contact info. Shout out to Looney Tunes for the address here. We can leave sys services alone. We won't have to change this unless we're doing more advanced configuration. I like to leave the master as agent X so it can run as optimally as possible. And then here at the agent address, this is where things change. Instead of it being the local host, I have it set to be UDP, any UDP address port 161 and UDP 6 on 161. This way, the Pi will listen to any incoming request for SNMP on my network. Now, a word of caution about this. If you plan on using this in production, do not do this, as this will open it up to any incoming SNMP connection that you could have on your network. Instead, what I would do is I would segment this off to a specific set of network addresses that can query the SNMP agent. For the full tree that we looked at earlier, we want to include more information, not less of it. So we changed it to be a view, and we call it all. And what's included is the full root of the SNMP tree. This will allow us to see all the different information that SNMP can read. We'll need to have this be reflected in our community as a read-only community IPv4 version. We'll call it public, and it will include default, -v, and the view will be all tied to our view up there. For other settings, we see things related to SNMP v3, as well as what we talked about previously in the tutorial if we wanted to piece out our SNMP config. But we're going to skip that now and move on to the next part. To monitor our Raspberry Pi using SNMP other than a localhost, we're going to need to find out our IP address. We can do this with ifconfig, and then from there, because I'm using the wireless interface, we can see it's 10.0.0.114. Monitor the Raspberry Pi from another device. I'm actually going to hop into my WSL Ubuntu instance. Now from here, we're going to have to repeat some of the same commands we did earlier to set up just the SNMP, not the SNMP daemon. So to start off, we're going to sudo apt-get. As you can see, I've already installed that. Same thing will go for our MIBS. And then once that's done, we once again want to go sudo nano etc snmp snmp.conf, and we're going to want to make sure that the MIBS line is commented out. This way our MIBS will load. And now if we do snmpwalk-v2c-c public, and instead of localhost, we replace it our 10.0.0.114, aka the IP address of our Raspberry Pi, and we do sysname, we'll see it'll return Raspberry Pi 5. So this is one of the ways that we can monitor our Raspberry Pi from another system. Now let's take a look at some of my favorite MIBs to monitor the Raspberry Pi, starting out with the CPU. So this MIB in particular, it will tell us what the idle percentage of the CPU. Minus that from 100, and we can see the CPU is only working at 1%. This is not too unexpected just because we don't have a lot of processes running currently on the Raspberry. For memory, I like to look at the following. This will tell me the real amount of memory available on the system. This is a great thing to monitor because if it gets too low, there are processes we'd have to kill off that are taking up the most memory. Now, if we come down to disk I/O, the first SNMP walk is going to list all the different disks that we have available to us. We can skip the loopback and we can skip the RAM, and we can jump back to the last disk, which is going to be the SD card main root files. When looking at that, we can look at what our I/O read operations are of all the I/O and read operations that have occurred on the device, as well as all of our write operations that have occurred. This is really helpful if this number gets really high or something. We also want to look at what processes are consuming a lot of the I/O. To monitor our interfaces for network traffic, we can do SNMP walk-v2c public, and again with the IP address of our Raspberry Pi. And we can look at this, which will tell us which interfaces are listed. And we see that we're going to want interface 3, because that's WLAN 0, the wireless interface we're using. And we can look at the in octets and the out octets. So these are great tools to monitor the Raspberry Pi and to be more in control of what's going on your network. And there you have it, the basics of how to monitor and set up SNMP on the Raspberry Pi. What are you looking forward to monitoring with your Raspberry Pi? As always, I'm Sam the Engineering Man, and if you have any questions or comments, let me know down below. I'll read them, I'll get to them, and I'll respond. And most importantly, I'll catch you all in the next one.